Hello class, welcome to the next lesson in 8th grade Eureka Math. We're working in Module 4 still. Today we're in Lesson 27, Solutions to Systems of Equations. We've been talking about systems of equations since Lesson 24. We're going to keep working on them today. And today we're going to talk about how many solutions a system can have and how to find a solution if it has one. So we're going to talk about how many solutions a system can have and how to find a solution. Now, we did find solutions in lesson 24 and 25, but we used graphs to find those solutions. Today, I'm going to show you a way to find the solution without graphing. That's the word, without. As a reminder, at the beginning of the lesson, you are in control of the speed. So if you need to pause the video to write something down, pause the video to write it down. If I'm going too fast, you need to go back and rewatch something, go back and rewatch it. It's easy enough. You are in control of the speed. You do what you have to do to get your notes, to get the knowledge, to succeed. Do what you have to do. Let's start our lesson with the vocabulary. We have 5 vocabulary terms today. So let's look at each of them. The first one is a review, system of equations. We've been having system of equations as our vocabulary word since lesson 24. A system of equations are linear equations that are related to the same situation. So it's a group of equations. And you remember to show that equations are in a system, you do a bracket that looks like that. That bracket shows that the equations are connected and exist in a system. The next 3 terms we have are all connected to how many solutions a system can have. So sometimes a system will have no solution, like we saw in the last lesson, lesson 26, about parallel lines. No solution is when the graphs of the 2 linear equations never intersect. If the graphs never cross, if they never intersect, then the system has no solution. This means the lines are parallel. So parallel lines have no solution because the graphs never intersect. Sometimes systems have no solution. Sometimes they have one unique solution. Just one solution. One set of coordinates that will make all the equations true. This happens when the graphs of 2 linear equations intersect once. And once only. So when the graphs intersect one time only, we say that's one solution, and that is the only point that is true for both lines for both equations. The third situation that systems can find themselves in, we have no solution, we have one solution. Systems can also have infinite solutions. Infinite solutions occurs when the 2 equations in the system actually make the same exact line. So if we have 2 equations that make the same exact line, we call that infinite solutions. And that is when the equations are for the same line. It's actually the same equation. It might just look different. And we've talked a little bit about that before, but we're going to see that again today. Our final vocabulary word is the method we use. This is the name of the strategy we use to find when there is one solution. So if there is one solution, we can find it by graphing. That's one method. Another strategy is the substitution method. This is the method we use without graphing. So this is a way to solve a system of equations by using y equals y. And we can use y equals y without graphing. If you're confused about what y equals y means, don't worry about it. We do talk about it in the notes today before we start our work. So those are the 5 vocabulary words: system of equations, what no solution means, what one solution means, what infinite solutions means, and the strategy called the substitution method to find solutions without graphing. So let's talk about what we're going to be doing today in math. Today, we will look at slope-intercept form, and that's important today. Today, to do all of this work, it's easiest if you have your equations in slope-intercept form. So the first thing you should do with your equations, if they are in standard form, change them to slope-intercept. It'll make your life easier. In fact, that's the first step that I'm going to ask you to do today. Check that everything is in slope-intercept form. So we will look at the slope-intercept form to determine, to decide if systems of equations have no, infinite, or one solution. So you are going to look at the equations and you're going to say that system has no solution. Or you're going to say that system has infinite solutions. Or you will say that system has one solution. And then if the system has one solution, for systems with one solution, we will find that solution. We will find the solution without graphing. So that's what we're working on today. And I actually have 2 more pages of notes. So we're not done with notes yet. I want to show you how to decide how many solutions something has and how to use the substitution method. So let's look at my next page of notes. My next page of notes talks about how many solutions an equation can have. And it's really just a 2-step process to decide how many solutions something has. So if the question is asking you, how many solutions does the system have? Does it have no solution, one solution, or infinite solutions? This is what you do. First step, you'd make sure it's in slope-intercept form. You make sure you have the first equation is in y equals mx plus b, and the second equation is also y equals mx plus b. They have to be in slope-intercept form first. After they're in slope-intercept form, and if they're not in slope-intercept form, use your properties to make them in slope-intercept form. But if they are, then you compare your slopes and your intercepts. And I have a little chart here. Compare your slopes and your intercepts. So look at my little chart. If the slopes are different, like right here in my 2 equations, I have the red equation and the blue equation. So if the slopes are different, if the red slope and the blue slope are not the same, if they are different, automatically that means there is one solution. If the slopes are different, there is one solution. And that might be the fastest one to find. That's why it's first on my list. Different slopes means one solution. It's that easy. Now, something happens if the slopes are the same. For the second star, if the slopes are the same and the intercepts are the same. So the red M equals the blue M and the red B equals the blue B. If M equals M and B equals B, if everything is equal, then you have the same line. It is just the same line. And there are infinite solutions. So if the slopes and the intercepts are the same, red and blue M's and red and blue B's, that's infinite solutions because you have the same line. Third situation, what happens if the slopes are the same and the intercepts are different? So red M equals blue M, but red B does not equal blue B. Well, if the slopes are the same and the intercepts are different, that means the lines are parallel. So there is no solution. Just like we saw in lesson 26, slopes are the same, intercepts are different, means parallel, means no solution. So this right here is pretty much lesson 26. But this chart, what happens if the slopes are different? What happens if everything's the same? What happens if the slopes are the same and the intercepts are different? This tells you, this chart will tell you if there is one solution, infinite solutions, or no solutions. So keep this chart next to you when you're doing your math today. It will really help you until you memorize, internalize these rules. One more thing I want to show you today. What happens if the slopes are different, you have one solution, and you want to find that solution? In lessons 24 and 25, you graphed to find the solution. But what if you don't want to graph? What if you want to find the solution mathematically? Well, that's where the finding the solution without graphs form. This is the substitution method. This right here is the substitution method that we did in our vocabulary list. So step 1 of the substitution method, finding solutions without graphing. That's the substitution method. Step 1, use slope-intercept form. Make your system in slope-intercept. If your system is in slope-intercept, awesome. If it's not, you need to put it in slope-intercept. This only works really if you have slope-intercept form. So after both equations are in slope-intercept and you have in your system, step 2, you need to know that the equations equal each other. Because they are in a system, the system tells you that they're related, that they're connected, that they follow the same kind of, they're in the same type of problem, which means because they are connected, this y and this y have to be the same because they are in a system together. The system tells you the y's are the same. So step 2, you have to realize, you have to remember that red y equals blue y. The red equation and the blue equation. The red y equals the blue y. Y equals y because they are in a system together. And so because y equals y, you get to write red y equals blue y, which means, here's the substitution part of the substitution method. The red mx plus b equals the blue mx plus b. The red mx plus b equals y. The blue mx plus b equals y. Y equals y, which means both of these are the same. They are equal. So make them equal. So you have mx plus b equals mx plus b. Step 3, use your properties right here to find the x. You're going to use your properties: division property of equality, multiplication property of equality, addition property of equality, subtraction property of equality. Whatever properties you need to use them in right here. Take this right here. Take this piece and find x. Use your properties to find x. So after step 3, you should know what x is. But you're still missing the y part of your solution. That's step 4. Step 4, you pick one of the equations, you put the x that you found in step 3. Take the x from step 3 and put it into one of the equations in your system. Does not matter which one. Just put it into one of your system equations. And then after you have the x, you can find y. So step 4 is use step 3's x to find y. And then step 5, because you find x in step 3, you find y in step 4. Step 5 is just to write your solution, because your solution is a set of coordinates, x comma y in parentheses. So you have your solution. I know that was a lot of writing. Let me show it to you with an actual example so you can see what I'm talking about here. Here's our example. We have a system, and both the red and the blue are in slope-intercept form. So that's step 1. Step 1 is just having a system in slope-intercept form. Step 2, y equals y. So the red expression equals the blue expression. So we had y equals 5x plus 6. We have y equals 4x plus 7. Because y equals y, they're in a system, so y equals y. We get 5x plus 6 equals 4x plus 7. That's step 2. Step 3, I use my properties. You can see I use the subtraction property of equality first. Then I use the subtraction property of equality again, and I found x. I used my properties. I took this, put it here, used my properties, and found x. Step 4, the next substitution, the substitution method, I pick one of the equations. For this step 4, I just picked the red equation. You can pick the red or the blue, does not matter. I picked the red. And so I have my red equation, and I take the x from step 3, I put it inside. I substitute, like substitution method. So now x is 1, because I found x is 1. And then I solve and find y. 5 times 1 is 5. 5 plus 6 is 11. So y is 11. So step 3 tells me x is 1. Step 4 tells me y is 11. My step 5 solution, 1 comma 11. That is the true solution for the red equation. That's the solution for the blue equation. That is the solution for the system of equations. And you can look, this is all of my work, and there is no graphing there. So this is how you find a solution from a system with no graphing. We are going to practice this. We are going to practice both things right now in our exercises. We're going to practice finding how many solutions from page 2 of my notes, and we're going to practice finding the one solution without graphing from page 3 of my notes. Very good idea if you have pages 2 and 3 sitting next to you of your notes so that you can look back at the steps and make sure that you have the chart for how many solutions, and make sure you have maybe this example sitting next to you for finding the solution so you know what your work should look like. But let's look at the exercises and see what they want us to do today. So, exercise 1 on page 335. We have a system of equations, and it's asking us to determine the nature of the solution to each system of equations. In other words, the directions can just say, how many solutions? That's what it's asking you to find. How many solutions? So this is page 2 of my notes. And if you remember, the first step was slope-intercept form. We need slope-intercept form. So these equations, well, the bottom one is in slope-intercept form. The top one is in standard form. So let me change. We'll do that one in red. 3x plus 4y equals 5 needs to be in slope-intercept form. First thing I'm going to do is subtract 3x from both sides. So I get 4y equals a negative 3x plus 5. Then I need to divide by 4 to get the y by itself. And I divide everything by 4. So I get negative 3/4 x plus 5 over 4. So now I can rewrite my system because I have both in slope-intercept form. I have y equals negative 3/4 x plus 5/4, and I have y equals negative 3/4 x plus 1. Now we need to decide how many solutions this has. So let's look at the chart. So first one, are the slopes different? In this system, the slopes are not different. They are the same. So slopes are the same. So we can write that down. Slopes are the same. Slopes are identical. What about the intercepts? We have 5/4 and 1. Those are different. 5/4 and 1 are not equal. So intercepts are different. Which one is that? Which one on our chart matches that? Same slopes, different intercepts. Same slopes, different intercepts. So here we go. Same slopes, different intercepts means parallel, means no solution. So that's what we can just write. Slopes are same, intercepts are different. That means we have parallel lines with no solution. And that's how you solve exercise 1. You get them in slope-intercept form. You look at the slopes, you look at the intercepts, and use the chart to find out what that is. Let's look at exercise 2, see which one that is. Now I'm looking at exercise 2, and I see 2 equations that are not in slope-intercept form. So let's change them to slope-intercept form. Let's get 7x plus 2y equals negative 4. I'm going to do minus 7x to both sides. So I get 2y equals negative 7x minus 4. Divide by 2. I get y equals negative 7 over 2x minus 2. So in my system, the first equation in my system in slope-intercept form looks like this. Let's change the second one into slope-intercept form also. X minus y equals 5. So I'm going to add y to both sides to get positive y. So I get x equals y plus 5. then I'm going to do minus 5. So I get x minus 5 equals y. And that's in slope-intercept form. I get y equals x minus 5. So now I have equations in slope-intercept form. That's step 1. So let's look at our chart. Step 1, slope-intercept form. Good. Now let's see which one it is. Let's look at our slopes. Let's look at our, so the slopes are different. Well, which one happens when the slopes are different? For no solution, the slopes have to be the same. For infinite solution, the slopes have to be the same. But for one solution happens when the slopes are different. So different slopes means one solution. There we go. Different slopes means one solution. And I'm pretty sure you can probably guess what the third question, what's going to happen for the third question. What's going to happen for number 3? Well, again, these are in standard form. Let's change them into slope-intercept form. We have 9x plus 6y equals 3. And you know, if you notice what I see from all this, I see 9, 6, and 3. I know all of those are multiples of 3. So I'm just going to start out with the division property of equality and divide everything by 3. 9x divided by 3 is 3x. 6y divided by 3 is 2y. 3 divided by 3 is 1. That makes it simpler for me. Let's get it in slope-intercept. So I'm going to do minus 3x on both sides. That gives me 2y equals negative 3x plus 1. Divide by 2 to isolate the y. That gives me negative 3/2 x plus 1/2. So in my new system with slope-intercept form, the first equation becomes y equals negative 3/2x plus 1/2. Let's see what happens to the other equation. 3x plus 2y equals 1. And already that might sound familiar. You might be thinking deja vu right here. Because if you look, 3x plus 2y equals 1 was over there. After we divided by 3, we got this equation. So this is why we're paying attention, we're focusing, because now I don't have to do any work because I know this equation, this standard form, changes into this. How do I know that? Because I already did it. It's the same equation. Our system has the same equation. So we have the slopes are the same. They are both negative 3/2. The intercept is the same. 1/2, 1/2. What happens if everything is the same? What happens if we have the same equation in our system? Well, if everything's the same, if slopes and intercepts are the same, m equals m and b equals b, that's the same line. So there are infinite solutions because one is right on top of the other. So in exercise 3, we have infinite solutions because the lines are exactly the same. Any x and y will work. Infinite solutions. So that page, 335, gave you a pretty good example of when there's no solution, one solution, and infinite solutions. You use the chart I gave you, use the notes, and it's pretty simple after you just look at the equations in slope-intercept form. It's easy to see if you remember that chart. Let's go to page 336 and see what other exercises they want us to do. Exercise 4. Let's see, I'm just checking right here. There are 4, 5, 6, 7. So we have 4 more exercises to do. And the directions, it looks like, for all 4 might be the same. Let's look. It says, determine the nature of the solution to each system of linear equations. So in other words, like they said before, first step, how many solutions, just like we did on the last page. And then if the system has a solution, find it algebraically. And then verify that your solution is correct by graphing. I'm not going to ask you to verify that your solution is correct by graphing. I want this lesson to go a little bit faster than that, so we do not have to prove it by graphing. I just want you to show me we're just going to practice this substitution method today. You know how to graph if you did lessons 24 and 25 with me. I'm not going to make you do it again today. I just want you to get the substitution method today. But remember, if I could still ask you on a quiz or a test to do both, you need to be able to find graphing solutions and substitution method solutions. So make sure you know how to do both. So how many solutions, and then find if one solution. So if there's one solution, it wants us to find it. So how many solutions, and then find it if there is only one. So looking at number 4, we have our system, but our system is not in slope-intercept form. And remember, step 1 is we need slope-intercept form. So let's change them. We have 3x plus 3y equals negative 21. And we have x plus y equals negative 7. Well, first thing I see, and this is what you want to get used to checking, you want to look and see if you can simplify before anything else. This is why knowing your math facts is super important, because I see 3, 3, 21. And I know all of these can be divided by 3. 3 goes into all of those evenly. So I'm going to use the division property of equality to divide everything by 3. 3x divided by 3 is 1x. 3y divided by 3 is 1y. Negative 21 divided by 3 is negative 7. And this might be where you want to stop and save yourself some work. Because if you are paying attention, you will see that this looks very familiar. This looks familiar, and there's a reason I'm circling it in blue. Because you see this exact same equation over here. So both the equations in our system are actually simplified to be the same, because the top equation turns into x plus y equals negative 7. And the bottom of the equation started as x plus y equals negative 7. Those look exactly the same to me. They are exactly the same. So what happens, how many solutions do we have in our system if everything is exactly the same? Well, going back to our chart, if everything is exactly the same, that's infinite solutions. So we can actually stop right here and just say that there are infinite solutions, because they are the same equation, same line, infinite solutions. And because there's infinite solutions, we don't need to do part B where we find the solution, because there's an infinite number. We're not going to just find one. So there we go. Number 4, we just simplified and we saw that they were the same. That's a great strategy to do if you think there might be infinite solutions. Simplifying first saved me a lot of time, because when I simplified first, I saw that they were the same. If you don't simplify, like the division property of equality right here, the division property of equality saved me a bunch of time. So you might want to practice your math facts, practice your division skills to save yourself some time. Okay, that's good. Let's look at number 5 now. Exercise 5. Moving on. We have 2 equations in the system. We need to figure out how many solutions there are. Now we got fortunate here because the first equation in the system is already in slope-intercept form. Y equals 3 over 2x minus 1. So that helps us out. But the second equation, not there yet. We need to change it. So let's change that into slope-intercept form. To do that, we're pretty close. We just want to isolate the y. Right now we have 3y on the left. To make that just y, we need to divide by 3. Because 3y divided by 3 is y. But the division property of equality says I need to divide everything by 3. So 1x divided by 3 is 1/3 x. Plus 2 divided by 3 is 2/3. So now that is slope-intercept form. And we're ready to do the first part, how many solutions? Well, let's look at this. How many solutions? I'm looking at this and I see the slopes are different. Green slope is 3/2. Orange slope is 1/3. So the slopes are different. How many solutions do we have if the slopes are different? Going back to our notes, if the slopes are different, there's one solution. That's why that page helps you out. So the slopes are different. There is one solution. And remember the instructions. They want us to find how many solutions. We did that. There's one. But if there is one, we need to find it. So let's find it. Because there's one solution, let's find it. And for that, you'll need the third page of our notes. The 5 steps. Now, luckily, we already did step 1. We have slope-intercept form. So we have slope-intercept form right here. That's step 1. Step 2, remember. So I'll even label the steps for you. Here's step 1. Step 2, remember that because they are in a system, they're connected. So y equals y. The green y equals the orange y, which means the pieces equal each other. So this is step 2, where we take the pieces and set them equal to each other. Now, step 3, I need to use my properties to solve this. So step 3, I'm going to use my properties to solve this. I'm going to switch to a different color because now we're trying to solve. 3/2x minus 1 equals 1/3 x plus 2/3. Now, you might be saying, that's a lot of fractions, Mr. Baylor. So the fractions might be freaking you out right now. I'm going to teach you a little trick right now to help you with this. Make the fractions go away. Make the fractions go away. The way to do that is you multiply to make the denominators disappear. Now, you might be saying, how do I do that? There's 2's and there's 3's. This denominator has a 2. This denominator has a 3. How do I make the denominators go away? Well, can you think of anything that has 2 and 3? What has 2 and 3 is 6. So you multiply both sides by 6 to make the denominators go away. Let me show you how that works. Because 6 times 3/2 turns into 18/2x. Minus 1 times 6 is minus 6. 1/3 x times 6 is 6/3 x. 2/3 times 6 is 12/3. And you'll notice this is all just division right here. 18 divided by 2 is 9, so we get 9x minus 6. 6 divided by 3 is 2, so we get 2x. Plus 12 divided by 3 is 4. Now, just multiplying everything by 6, where did I get the 6 from? I got it from my own head, because I said I want to make the 2 and the 3 go away. That means I need a 6. So now this is integers. This is whole number coefficients and whole number constants. I can use my properties to make that go away. First thing I'm going to do is I'm going to move the x's to one side. So I'm going to do minus 2x over here, minus 2x over there. So I get 7x minus 6 equals, well, 2x minus 2x is 0, so I just get 4. Next, I want to move the 6, so I'm going to use the addition property of equality and add 6 to both sides. That gives me 7x equals 4 plus 6 is 10. Then I'm going to use the division property of equality because I don't want 7x. I just want x, so I'm going to divide by 7. So x, 7x divided by 7 is x. 10 divided by 7, just keep that 10 sevenths. So x equals 10 sevenths. Makes that much easier now. X equals 10 sevenths. Now, step 4, I take my x and I put it into one of my equations right here. I put it into one of these. Now, which one? It really doesn't matter. Does not matter. I'm probably going to pick the one where I just do -1 because I think -1 is easier than plus 2/3. So let's do that way. Let's take y equals 3/2x minus 1, and x is going to be 10 sevenths. So I get y equals 3/2 times 10/7 minus 1. Now, already you might see something right here where 10 is 2 times 5. So the 2's can cancel. 2 divided by 2 is 1. So I keep the 5, the 2 in the numerator and the 2 in the denominator go away. So that gives me y, 3 times 5 is 15. 1 times 7 is 7 minus 1. So I get y equals 15 sevenths minus 1. Well, 1 minus 1 whole, that is just 7 sevenths. 1 is 7 divided by 7. But why did I change the 1 into 7/7? To make it easier to subtract, because the denominators have to match. So I stay the same denominator, but 15 sevenths minus 7 sevenths is 8 sevenths. So now I have x from step 3. I have y from step 4. Step 5, which I'm going to write over here, is my solution. The answer is x was 10 sevenths and y was 8 sevenths. That is my solution. Those are the coordinates that will make my system true. A lot of work, but really it makes sense. It's organized. It's 5 steps. Do one step at a time and don't let it freak you out too much, and you'll be just fine. We do have a couple more exercises. Let's look at exercise 6 right now. See what happens for this. Now, exercise 6, they try to mess us up a little bit because we have x equals instead of y equals. So what we should do for this is we should still follow the rules. You might think you know what you're doing, but let's still just follow the rules and get it into slope-intercept form. Let's just get it into slope-intercept form just to help us out a little bit. So let's change x equals 12y minus 4 into slope-intercept. So we're going to add 4, so we get to both sides. So we get x plus 4 equals 12y. Then we're going to divide by 12. So we get 1/12 x plus 1/3 equals y. So the first equation in our system is y equals 1/12 x plus 1/3. For the next equation, we also have to change that into slope-intercept form. So let's do -7 on both sides to try to get the y by itself. So we get x minus 7 equals 9y. Then we need to divide by 9. So we get 1/9 x minus 7/9 equals y. So our second equation is y equals 1/9 x minus 7/9. So let's look. What are the slopes? The slopes, let me go back. We have slope-intercept form. Now we're ready to compare them to find out how many solutions there are. Looking at this, you can see that the slopes are different. So the slopes are different. And if you remember from the notes, different slopes means there is one solution. One solution. Different slopes, one solution. So, and remember, we have how many solutions, and if there is one solution, we need to find it. So let's find it. So remember, 5 steps. Step 1, we have slope-intercept form. Step 2, and this is where you might want to get a little bit tricky, because I told you step 2 means y equals y. But also in step 2, and here's another thing that's true, because these are in a system, the system tells us that y equals y. But this problem is especially fun because we can also think that they are in a system, so x equals x. Because they are in a system, the solution has to be the same. Y equals y and x equals x for the solution to this system. Now, if you look at, now that is true. I did not tell you that in your notes, but I'm adding it to you now because it is useful for this problem. The reason it is useful for this system is because if you look at the system with y equals, a lot of fraction is difficult. But if you look at the system with x equals, that looks more fun to do. So I'm actually going to, instead of doing y equals y, I'm going to do x equals x. And I'm allowed to do that because it's in a system. It's also true. So step 3, I'm going to write y, I'm going to write not y equals y, I'm going to write x equals x. And I'm going to use the version of this system with integers. These are actually the same system. Just this has x equals and this has y equals. Same system. I'm going to solve that one though, because that one looks easier to me. So I'm going to get 12y minus 4 equals 9y plus 7. So let's solve that. Let's solve that. I'm going to use a different color so that because we're trying to find y right here. First thing I'm going to do is I'm going to move the y's to just one side by doing minus 9y on both sides. So I get 3y minus 4 equals, well, that turns into 0, so plus 7. I'm going to add 4 to both sides, so that gives me 3y equals 11. Going to divide by 3, so I get y equals 11 thirds. So y equals 11 thirds. For step 4, I'm going to substitute, and I'm going to pick the one I want, and right here, I see 11 thirds. I think it could work with either one, but I'm going to pick the equation with the adding. I'm going to say x equals 9 times my y plus 7. I really can pick whichever one I want. I'm just picking that one for fun. So I take this y and put it back into that equation. So x equals 9 times 11 thirds plus 7. And 9 is 9 over 1, just to help us out with multiplying the fractions. I'm going to simplify this before I work because I know 9 is 3 times 3. So this 3 in the numerator can cancel that 3 in the denominator. So I'm left with 3 times 11 over 1 times 1. So I get x equals 33 plus 7. So x equals 40. So I used my system. I thought x equals x. I found y. I used the y to find the x. And then step 5, my solution is going to be taking the x, which was 40, taking the y, which was 11 thirds, and writing them like coordinates. That is my answer. So this system has one solution, and that is the solution. Good enough. In fact, so good enough, I'm going to skip exercise 7. That's the exercise, that's the notes, that's what we're doing today. You're finding how many solutions using page 2 of your notes. And if there is only one solution, you use page 3 of your notes to find it. Let's talk about your independent work for today. You have the lesson summary on page 338, which you can read. It has everything we talked about. You have the exit ticket on page 339, which I'm going to slide to the back because that's the last thing you do. On page 341 and I believe 342 and 343, you have your homework helper where they give you the question, they tell you the answers, and they tell you what they were thinking when they did it. So use the homework helper. It is super useful if you need more examples. And then page 345, you have the problem set. There are 11 questions on this problem set, and it's asking you to find the same thing we just did together in the exercises. How many solutions? And if there is one, find it. So how many solutions? If there is one, find it. And then it says verify your solution is correct by graphing. I'm going to say you don't have to do that today. You can do that if you want, but you do not need to graph to prove it. Just how many solutions, and if there is one solution, I do want you to find it. Remember, my answers to the problem set are posted on the Google Classroom, so you can look at those to check your work anytime. To make sure you know what you're doing. And also remember that I am available anytime to help you on any of this. You just have to reach out and ask, and I will help you no problem, give you more advice, walk you through a couple of these on the problem set. I will do some of the problem set with you just to help make sure that you master it. When you feel confident, then you are ready to go back to page 339 and work on the exit ticket. And there are 3 questions on the exit ticket. And yes, you're doing the same thing. How many solutions? And if there is one solution, find it without graphing. That's what you're doing today on the exit ticket. So do that when you feel confident, after you've asked for all my help, after you've checked your work on the problem set with my answers. Work on the exit ticket. But that's all I got for the lesson today. Remember to reach out to me for help if you need it. Work hard, persevere, don't give up, and I'll see you for the next lesson.